Okay, really quickly, I would just like to go over vertex form of a quadratic and what happens when we change the values of a, h, or k. Hi, my name is Mr. Brash. This is going to be a really quick and detailed video. All right, so here we have a quadratic. This is the base quadratic or parent function of y equals x squared. Even though you see a, h, and k in the equation, the reason why it's y equals x squared, a is a 1, h is currently 0, and k is also currently 0. And so really, h doesn't exist, neither does k, and a is just a 1. So individually, we're going to figure out what do those three values do to the equation. And we're going to start with a, and I'm going to increase the value of a. We're going to take a look at what happens to the parabola as I increase that value. We're at 3, we're at 4. I'm going to go back down to 2 and back down to 1, and it's almost like it's doing aerobics, and it's back down to about 1 and gets back higher and higher up all the way to 10. So what's happening to my parabola? Well, it's getting thinner, but what's actually happening is it's getting taller. It is vertically stretching, and as I bring it down back down to 1, we're compressing back down to its normal value. And what that does is it actually pulls the tops of the parabola up. Think about like an elastic band, and it has to get tighter together in order to do that. That's a dilation, just like your irises and your eyeballs, they dilate. And in this case, it's getting tighter or stretched vertically. But watch what happens when I get below 1. It gets a little bit squished, and a little bit more, and a little bit more, and a little bit more. Right down, I'm at 0.3, I'm at 0.1. I'm going to add a 0.1, actually a 0.05 rather, and let's go to 0.025, 0.01, and look at that, we are fat out left and right. That has been vertically compressed, almost like somebody's stepping on it, so my parabola has actually gotten shorter. So this a value that causes that dilation, I like to call it the amplitude, just like an amplifier. It decides if your parabola is taller, i.e. louder or bigger, or shorter. And it's exactly what you think it would be for height. So if I say be 1 times your normal height, okay, I'm just my normal height. If I say be 2 times your normal height, you're going to be twice as tall. If I say be 5 times your normal height, you'll be 5 times taller. But in any of those cases, if you have to keep your weight the same, well, you have to get thinner. And if I say be half your height, which would be 0.5, then you're going to have to be a little bit stouter, a little bit wider, a little bit thicker, because you are half your normal height. And if I say be 1/10 your normal height, you're going to have to be squished down even further. So that a value controls that, but it gets a little bit more interesting when a is negative. Let's take a look what happens when I get past 0. Well, actually, when I'm at 0, let's take a look at that. I'm flat across the x-axis because a is nothing, and I just have the horizontal line y equals 0. But look what happens when I get into the negative values. So that makes my parabola open downward. I am now concave down further and further and further. Concave up, concave down. And so that also provides what we call a reflection over the x-axis. So when a is negative, we get that reflection over the x-axis. The h value, I like to remember that as the horizontal modifier. And so if I slide to the right here, it slides to the right. If I slide to the left, my parabola slides to the left. But what's really important to understand is that this has x minus h, x minus h. And so if h is positive 4, that's actually saying x minus 4. So it gets a little bit confusing. So I'll write this down. Y equals x minus 4 squared. And you can see I'm right on top of my other parabola here. I'll bring the orange one back down to the left. And if I have over here at h equaling -6, let's say, so I'll write that down. Y equals x minus -6. Well, what does minus and minus do, or negative and negative, or any of those sorts of things? It turns it into a plus. So this is like saying x plus 6. And I get my parabola over there on the left. All right, so the h can be a little bit confusing in that sense. The equation is written x minus h. If it is x minus 4, that's a shift or translation to the right, just like this. And if it is x plus a value, it's actually a horizontal translation or shift to the left. So keep that in mind. Last is the k value, which is the vertical. That's how I kind of remember it, is the k in vertical. It does exactly what you would think it does, and there's no tricks. It moves it up or it moves it down. And so with the combination of h and k, I can move my parabola up, down, left, right. With the a value, I can make it taller, thinner, flipped upside down. And that's what allows me to transform or move my parabola around the screen. And if we take a look at what my h and k actually are, they're the values of the vertex, believe it or not. So that h and k, that is the vertex. So as I shift this parabola around, we can see that the numbers change for h and k. So here I'm at about 2 and 2. And maybe let's go over here to 4 and 2. And I can see that my h is about 4 and my k is about 2. And that is how we would write our equation down. And so as I move these sliders, the a does not change where the vertex happens. It just changes. I'm flying like a bird here. And if I move my h to be more negative, it moves to the left. But as I write it, that means minus a negative. And my k value moves things up and down vertically. And those are the most basic transformations of a parabola in a quick and detailed format. My name is Mr. Brash. I hope that all made sense. Of course, there are other videos online like Khan Academy and such. Feel free to leave a comment or a question. Like the video if you liked it. May even want to subscribe to my channel. That's totally up to you, but I'd appreciate it. Have a great day.